Okay, this is AS Mechanics, AS Math, paper 4-2, question 4, 2022 October, November. A car of mass 1,200 kilograms is traveling along a straight horizontal road, AB. There's a constant resistance force of magnitude 500 newtons. Okay, this is important. So the resistance force R is equal to 500 newtons. Let's write it down over here. Okay. You're given the mass is 1200 kilograms. Okay, when the car passes point A, it has a speed of 15 meters per second. So V at A is equal to 15 meter per second, and the acceleration at A is equal to 0.8 meter per second square. What are they requiring? They're requiring the power of the car's engine at the point A. We know that the power is equal to the force times the velocity. We have the velocity, but we require the force. Knowing the mass and knowing the acceleration, we know that F is equal to ma. But this is in the case of if you have one force, right? But what's the problem here is that we also have a resistance force, right? So this F equals ma is F net is equal to ma, right? Without the vector symbol. What's the problem is that we have a resistance force. So we need to use the net force. I personally don't like doing this. Whenever I have to use forces, I always like drawing the FPD. Okay, always, whenever I have forces and I want to use force and I have like a diagram and something moving and resistance forces, I draw the FPD. I have the weight going down, I have the engine force going to the right, and let's just call the resistance force R backwards, and we have the normal reaction. So we know it's accelerating, so you can say sigma Fx is equal to ma, which implies that since we're moving in the engine's direction, E minus R is equal to ma. So you can continue over here. E minus 500, substituting R for 500, is equal to the mass 1200 times the acceleration 0.8. Let's start substitute. Let's calculate it. You can get 1200 times 0.8 plus 500. You're going to get 1460 newtons. Can we now apply P is equal to Fv? Of course we can. So P is equal to the force times the velocity. So the force is 1460. The velocity is 15. So you do 1460 times 15. And you get 21,900. So P is equal to 21,900 watts, or P is equal to, if you want to put it in kilowatts, 21.9 kilowatts. You need to put the unit, okay? The marking scheme says if you put 21,900 without units, it's fine. But 21.9 kilowatts is also fine. But if you say 21.9 without units, it's wrong, okay? You need to put, in my opinion, don't take a risk. Always play it safe and put your watt unit. Okay, for part B, they say that the car continues to do work with the same power as it travels from A to now a point B. The car takes 53 seconds to travel from A to B, and the speed of the car at B is 32 meters per second. So what do we know? We know that the power is the same, so it equals 21,900 watts. We know that delta T is equal to 53 seconds. And we know that VB is equal to 32 meters per second. Now, what somebody would usually do is they would use the UARM equation. They'd find the acceleration and find the distance by using V squared minus U squared equals 2AX. Or they can use U plus V over 2 times T. That's completely fine. But what the thing is here, you don't know if the acceleration is constant. So when you have power you guys know is work divided by time. So there's a change in energy. So the reason you cannot use the UARM equations is because you don't have a constant acceleration. The acceleration is always varying when you have power. Okay, up here we could use it because we're talking about at the point A. Okay, here we're talking about the distance from A to B. So since you have power, you're not allowed to use UARM equations. Okay, so you're going to tell me, okay, Walid, well, what do I do? I mean, we have our first velocity. We know that VA is equal to 15 meters per second, right? It was up here. Okay, VB is now 32 meters per second. We want to find the distance AB. We have the power and we have the time. Don't you know that the work done is equal to the power multiplied by the time? So we're kind of getting there. We're getting some hints. So we have the power, we have the time, so we can actually find the work there. And we have velocities at two different points, at the first point and the last point. So you can also find, whenever you have velocity at the first point and at the second point, that means you can find the kinetic energy of the first point and the last point and see how much was the change in the kinetic energy. Because you know that delta KE is equal to work net, right? So the net work is equal to the change in kinetic energy. So K final minus K initial is equal to the net work. So let's start. K final, I'm not gonna do K final. Fine, I'm not gonna find them separately. I'll just do it. So half mv final squared minus half mv initial squared is equal to the net work done, right? Let's see. We're gonna start substituting. Half times the mass, it's 1200, times velocity final squared, so times 32 squared, minus half the mass initial squared, which mass initial is 1200. Should mass initial, we always have mass, it's the same, the mass is the same, 1200, times v initial squared, now we square 15 squared. Okay, and on your calculator, when you do this, you get over here 0.5 times 1200 times 32 squared minus 0.5 times 1200 times 15 squared, and you get 479400. So work net is equal to 479400 joules. So we're getting somewhere. We know that the work net, so we have resistance, right? We have resistance. If there was no resistance, you could just do work net is equal to force times distance, and you're done. But we can't do that because we have resistance force, right? So for that reason, we know that work net is equal to work done by the engine plus work done by the resistance force. Usually we call it friction, but here they're saying resistance R, so we can just say R. Okay? Work done by the engine is equal to the power times time. So it's just going to be equal to 21,900 times 53, and you should get over here 11,60700. So it's equal to 11,60700. Okay, so this is work done by the engine. What's the work done by the resistance force? We don't know anything about the resistance force other than the force, and we know that the work done by the resistance force is equal to negative the force times the distance, right? So it's equal to negative 500 times the distance d that we're trying to find. So let's see this. We have work net, we have work done by the engine, we know work done by the resistance force other than the d. So can't we just solve it for d? So let's see. Work done by the net force, 479,400 is equal to 11,60700 minus 500d. Let's just say equals negative 500d. So minus 500d. Can't you solve this equation? Of course you can. So you're going to subtract by 11,60700, and you're going to divide by negative 500, and over here you get 1362.6 meters. So d is equal to 1362.6 meters. Let me show you the marking scheme. This, by the way, if you want, is the ChatGPT explanation for why you can't use your ARM equations. Anyways, so this is the marking scheme. It's 3 marks. You get 1 mark for showing change in kinetic energy, 1 mark for showing the work done by the engine, because you have, this is the change in kinetic energy and saying where this is work net, 1 mark for showing the work done by the engine, and then showing the distance. And to show the distance, you have to say that, like we did here, this stuff. Okay. Anyways, that's it for this one. Thank you so much for watching, and good luck in whatever exam you're doing this for.